Okay, so let's start. So we have our panel on ethics and technology. And what we want to do, we want to talk about ethical implications of computer science and the development and use of technology, and on how technology affects the rights and obligations of individuals and society. And I think that's quite a broad topic. We are very lucky to have a number of renowned panelists on the panel, computer scientists who have a lot of experience in their field. First is Henning Schulzrinne. He's a Levy Professor of Computer Science at Columbia University. Eric Berger from Georgetown University. He's Research Professor of Computer Science. Then we have Lance Fortnow, the Dean of the College of Science at Illinois Institute of Technology. Anita Nikolich, a researcher in cybersecurity who is a visiting fellow at Illinois Institute of Technology. And Vijay Gurbani, who, if I understand this correctly, initiated this panel, which I think is a fantastic idea. He is a chief data scientist of Whale Systems, and he is an adjunct professor at Illinois Institute of Technology. So thanks everybody for being here and talking with us about ethics. I'd like to begin with asking you more about your own field of research and about what you think are important ethical issues in your field, because you are the specialists. Yeah, maybe you just want to begin.
Let's see here. So I'll broadly take my field to mean networking and related internet type of systems in that. So I think the basic ethical issue is that we're essentially dealing what has become clear in other areas it's called dual-use technology. So I don't know if that term is widely used, but my notion is that this is typically used for export-import type issues, where a technology can be used for civilian, generally taken as good purposes, and it can be used for military purposes, as in can be used to heal and to kill if you want to take it to extreme pace in that. We didn't used to think of the internet that way, in the sense that the emphasis was always on kind of the good part. Presence of internet would improve things in a variety of dimensions in that. And that is no longer, I think, a sustainable fiction. And so the ethical issues that often the amplification effect that the internet allows seems to be just as good, if not better, of amplifying some of the worst human tendencies than it is to amplify the better of angels among us. So I'm sure we'll get more into detail, but that's kind of my broad thing, is namely how has the internet changed as an amplifier, really, among actors that we don't want to amplify.
And thank you for reminding me of the in that one of my students graduated 2 years ago, and his thesis was literally on dual-use technologies. However, his thesis was in science, technology, and international affairs. So he's in what we call the School of Foreign Service, which is our international affairs school at Georgetown. And I think that's also an important thing is, and I'm sure Lance, you're probably looking at this kind of stuff too, is we don't think anymore, we try not to think of computer science. We try to think more broadly. So like computer science and international affairs, computer science and business. And some of these issues are new. So, his investigations were into tools that are used for detecting malware on your network or detecting dissidents in your country. Same technology. The technology doesn't know what's right or wrong, but it's how it's used. But yet, his formal training was in like chemical warfare, where precursors to, the poisons are, and bombs. Phosphorus is fertilizer, dual-use technologies. And so looking at how, basically the things that are the same, but also the things that are different from the new technologies that we're creating, and the realization that it's not this scary new thing we don't know how to deal with. A lot of it actually fits into our existing norms, and kind of like the philosophers have worked out what's good and evil, 1,000 years ago. We might want to look at some of that stuff.
So my research background is actually theoretical computer science, and I have an advantage there in that everything I've done has no practical value whatsoever, so less ethical issues.
You said that.
But I spent 7 years as department chair in the computer science department at Georgia Tech, and now as dean here. And you can't help but think of all the ethical issues. I mean, it's just so many to go around. Probably the biggest is just that for many years we've not thought about them. We just kept thinking of the goal was to make computing as good and as powerful as possible. And now, I mean, I still think that's still a great goal because there's a lot of great good that comes from computing. But we don't often stop and think, and we're starting to do this now, but we haven't done it for too long, stop and think of what actually is going to the effects of that. And probably the one that I've been the most interested, I mean, there's so many issues, but the one that I've been the most interested in is what's the future of work? What's going to happen as we get to the point that we can automate a lot of jobs that are out there? And not just simple mechanical jobs that maybe we can get robots for, but, good, I mean, a lot of middle class jobs that are out there that just we might be able to automate away. What's the world going to look like when that happens? And that's something that just we're still trying to figure that out, and there's no great solutions as we try to explore that.
So I always tell people I work in this gray area between kind of the academic world and the other world, other side of security. And I've always been in the middle, and that makes it really tough. Security research is really tough for academics because there are lots of different rules, Computer Fraud and Abuse Act, DMCA, there's all sorts of structure about what you can't do, which makes it really hard to legitimately do security research. It makes it really hard if you are an average person who's really interested in security, who wants to help society and expose flaws in things like pacemakers. It makes it hard to do that kind of research because there are so many limitations on what you can do. So kind of all the ethics that surround that are still, they're being magnified now with all the different IoT technologies. So what concerns me is where does security research fare? Are people going to really take the risk to do this if it means they may lose their jobs? And in academia, that's a very significant challenge.
Thanks. Yeah, so I don't think I can add more than what my distinguished colleagues have said. I mean, I think one thing that I find fascinating is we as technologists create the technology hoping that it'll do change and that change will be good. But many times it doesn't quite turn out that way. I have a couple of examples. One example is how many of you now, when you talk to your bank records your voice and say that they will use it for fingerprinting, for audio fingerprinting, right? So typically I tend to say I don't acquiesce to it. And the reason is because A, it's easy to mimic somebody. You've all heard Dana Carvey do George Bush if you're of a certain age. So it's easy to mimic somebody, but more importantly right now, just taking a few seconds of your speech that's being recorded right now as it is, and extracting the phonemes from it, we can create custom voice. And if I do that, and this custom voice says I'm Vijay Gurbani to my bank, and it matches the fingerprint they have, voila, right? So that's fascinating to me about the technology and its implications. And the second thing that I find fascinating is this whole notion of having these AI, intelligent, so to speak, beings, and the idea of nature versus nurture. We all know that twins put in different backgrounds will evolve differently depending on the nature, right? But an interesting experiment occurred when Microsoft Research released their bots. Tai, I believe, was released on the Reddit news group. And the exact replica of Thai, same code base, was released in China. And the bot that was released on the Reddit learned how to curse, learned how to be racist, learned how to do everything that it shouldn't.
In like 2 hours.
Right. And the one in China didn't. And the question here is not, is obviously these things will pick up what they're told, what they're taught to a certain extent and told. But the more interesting thing is where, so I mean, we could go further down this, but that to me is fascinating, to have these genetically similar components exhibiting vastly different behavior depending on the specific environment they are in. So I think from a computer science perspective, there's lots of interesting things to look at in ethics.
Yeah, thanks a lot. There's really a lot of ethical issues already. So you had this example with the bots and with a machine learning question basically, and with a question, why do they end up so differently, and why do they? This is the algorithmic bias problem, isn't it? The point that some bias may come in a system without being actively coded, but just implicitly ends up there, and that's one of the huge ethical issues around networks, around artificial intelligence at the moment. And maybe some of you can contribute some more examples from your experience and talk about the problems going along with this.
Well, actually, I'm going to make another plea for anyone who heard my earlier keynote. I'm going to say the same thing again. So I moderated a panel at University of Colorado, and it was mostly lawyers, but it was on algorithmic bias. And the thing is, the lawyers have been doing internet-y stuff and computer science-y stuff kind of new, but a lot of the policymakers were just like, oh, the algorithms are biased, so can't you program the algorithm to not? And it's like, no, these are machine learning algorithms. This is not that we've programmed it. And so the plea is to be involved, brief your state legislators, your members of Congress, to educate them, not this is good, this is bad, but just what kind of the technology is about. And then we can have all the nice research of, well, and in a sense, how do we correct bias? And I was saying this 20 years ago, so long before I was a regulator. But the reason we have regulation is because the free market didn't work in some respect. There was a monopoly we needed to change, or some investments wouldn't be made if we didn't. And if you look at bias, I guess the word bias is biased because, well, this is the training data. This is what people did before, so we'll do what people did before. Oh, but we don't like it. So how, a good research thing is, how do you introduce bias? But it's a different kind of bias.
So one thing is the regulation afterwards. We have the system with the bias, and then we have the regulation, which may be a really good idea. I mean, I agree. Another approach could be to try to avoid bias and think about how do we feed the system, what can we do? You wanted to.
So let me just maybe amplify that a little bit. I see two things happening that are namely, one is where we've had opaque systems that were human-driven but opaque. And I'll give two examples. And now these are somewhat being automated in some sense, and so it is both now easier and harder to see that one. So I'll give you two examples that are close to kind of more academic realm, where all deal with, namely admissions to college admissions and job interviews, kind of very high stakes decisions that largely, until fairly recently, were where my guess would be, anybody who's been close to the process knows that A, they're biased, and B, they're arbitrary. There is a fair amount of, we looked at master's admission at Columbia, and we found that all the numeric inputs that we typically use in that had very little predictive power as to how well they did in the program. And job recruiting has been traditionally known to be, even if it was no computer involved at all, it was biased in a variety of very well-known bad ways, racially, by gender, as well as just by other less legally protected dimensions in that. And we're now making that explicit. To some extent, I think that's a good thing. Because we now have a record of, we know the black box in the middle, but at least we know what all feeds in it. So for example, we know that whether the candidate had a spoken accent or not might not have been part of a decision. So we can maybe rule out that that mattered, maybe indirectly it did. And so that is, the question is, what can you do about it? And one is probably a humility recognizing that many of the decision processes that we have not automated in the past had more randomness in life, added more randomness in life than we probably were willing to admit. Where it was a notion that this is a fair process, whoever got into Harvard, Yale, whatever, deserved to be there, whoever got the job deserved the job, in that, leaving some bad actors aside who got their cousin or a nephew in, and that worked. And we have now much more, and I think AI forces us to be much more humble that many of these processes are inherently biased, simply because there's a notion of what bias means. In many cases, I think it was criminal justice, where depending on how you define bias, you get very different results in what's the metric you use in terms of, is it racial bias, is it outcome-based bias, whatever it happens to be.
Just a quick short comment. There's an excellent book by Kathy O'Neill called Weapons of Math Destruction. My advice is, if you haven't read it, go through it. And one of the points that she makes that's very pertinent here is the fact that we as humans have biases, but we learn to retrain ourselves to eliminate those biases. And one of the things that we are seeing is that these models are put out with biases, but there's no feedback loop to go back and retrain them to make them any better. In the absence of such feedback loop, we'll have to live with the decisions that these models make, as biased as they might be. Oh, that I don't remember. Don't put me on the spot, Eric.
Well, I thought you could see. So, like, one of them was whether it was correctable. Another one was, did it have mass effect? You know, like if it affected a person, probably not a big deal, but if it, could ruin it. But there was a third one as well. I can't remember.
One was...
So definitely read the book and come back
it's
to
a
me.
really
That's your
good
homework
book.
assignment.
I agree.
Weapons of Math. Yeah, as math.
MA of math destruction, not of, not of math, but of math of mathematical destruction, yes. So I think there are two aspects. So one is the systems, they tend to perpetuate the current situation. When you feed the system with white male people being more successful than other people, this is how we end up with. The other is that you mentioned this, the black box thing. We don't really know how the system comes up with a decision, and if we also all human beings, as human beings we have biases, but this is the gut reaction. But then we start kind of deliberating about it. We start thinking about it explicitly with language. We start a rationality process, and then we may be able to come up with a deliberate decision, a deliberate form of behavior. We may or may not. I mean, we all know there are problems. With a system, we only have this black box. We have only the kind of gut part of it. It's difficult to understand. I think that's a huge problem. We kind of rely on it and don't really know how it came up with a decision. So how do you think of this, especially, Well,
I'm going to start. So, there's a lot of issues you're unpacking there. So, first of all, a lot of modern machine learning techniques produce, they learn from data, but what they produce is a system which is very hard to understand what's going on in the black, why it's making the decisions that it's making. And there's a trade-off there. You can learn in ways that you'll understand what's happening, but you're likely to have far less accuracy in the results that you have. And companies tend to make money off the accuracy, so they tend to prefer that. There's also the issue of if you have something that's fully explained, people can take advantage of it. People can, like if you knew how a search engine ranked web pages, or you knew how a jury system decided what an outcome, how much money someone would get in a lawsuit, then people would manipulate the inputs, just like the way that people manipulate their tax returns, because you know exactly what the rules are, so people will work their income to get the best outcome. And there's some negatives to trying to fully understand the system as well. I think a lot of it comes from the data. I mean, it's very rare that I think someone actually programs biases directly into algorithms. I think most of it comes from data. If we learned biases, then the machines will learn them as well. And, oddly enough, it's strange because a lot of these things were developed to avoid biases. People were saying, listen, human judges, for example, can be very biased. So in order to avoid biases, we'll go to a very algorithmic approach that looks like it avoids biases. And sometimes that works, sometimes it doesn't. I mean, one of my favorite stories has nothing to do with computers at all. It's how compositions of orchestras. So orchestras used to be almost all male. And what happened was there was some sort of conflict of interest. There was a conductor whose, I think, son or someone like this wanted to audition for the orchestra, and they wanted to eliminate the conflict of interest. So what they did was they had a curtain, and they had people perform behind a curtain so you couldn't see who was performing. And when they started doing this, all of a sudden there were a lot more women being put on the orchestra, and this is now standard procedure now. You always when the major orchestras do auditions, they do it behind a closed curtain, and they're very careful with noises from shoes or whatever that might give away the gender of a person, and you end up with a much fairer system. So sometimes, oddly enough, the right way to solve algorithmic bias is to remove the data than to add it. But even that's tricky because you can remove every marker that you think has to deal with the race, and machine learning is good enough to still figure out what the race is and discriminate against it. So none of these things have easy solutions. And it's not even clear what fairness means. What is fair? And then there's different, is fair making sure that we have exactly the same racial breakdown as society does? Or is fair means that we ignore the race and we just give people based on what their test scores are? And the answer to both those questions is probably no. So these are incredible, tough things. There are a lot of smart people trying to figure it out. But the best thing I think we can do as computer scientists is frame the questions and then make sure that the policy people understand what the challenges are, what the tools are out there that they can rely on.
Yeah, this was a strong plenary towards the black box, in favor of the black box. Do you all agree? Or, I mean, your example was a good one. I know this from the Berlin Philharmonic. This was exactly the situation. They only accepted male participants, and things change, yes?
Yeah, the problem, I think, is partially, and you made what a good example is, there are some things where it's probably relatively clear what the performance is. Trained musicians can presumably judge, leaving aside the gender issue, whether somebody is either qualified to play in the Berlin Philharmonic or not, just by listening to it. I wouldn't be able to tell beyond just a very basic level, but and probably in sports and some other disciplines, that's relatively predictable, for experts at least. The problem is that we've created a number of very high stakes decisions in life, and I mentioned two of those, but you can think of medical insurance, you can think of others, where I think the problem, and you mentioned it, is inherently difficult, and the problem has gotten worse because we've made decisions much more high stakes. So for example, and this is again one where in many European university systems, you don't have this gradation between kind of a Harvard's and kind of the low-ranked state university in terms of where you went to university. Just, it doesn't determine your life future to that extent. So the admission process becomes much easier. You can still distinguish yourself at the university in a variety of ways, and you will do that, but it is not one, oh, if I didn't get admitted to a highly selective school, so a whole set of other opportunities are no longer available, and so you now have this inherently difficult problem. How do you tell, looking at an 18-year-old or 17-year-old, as to how they're going to do in life in that? And so removing the right decision, I think, in that case, to say you're asking a decision algorithm to make a decision which is inherently impossible both for a human and a machine. Thou shalt not do that. Just adding machine learning to that doesn't make the problem better. It just simply removes responsibility, as in they're no longer humans. You have to say, admission officers, you know to be fallible. It is now things that are more shifting blame, and my sense is often the use of these techniques is often to shift blame, as in the machine said it, must be right, no longer you can't blame the university president anymore, or whoever is eventually responsible for that.
Yeah, but that's exactly the problem, isn't it? In the end, nobody is responsible, or maybe the machine is responsible, or, I mean, who is responsible? Maybe with your example with the orchestra, yes, the male people behind, they were to blame, but maybe they should have reconsidered things. Maybe they should have come up with a better way of decision making. Yes, there is someone responsible, but with a computer system, who is to blame? Who is accountable?
Well, I mean, if Facebook consistently recommends certain articles, Facebook's to blame. I mean, that's pretty clear for some of these systems. If your insurance company jacks up your rates because they've aggregated and bought a bunch of data about you, put it in their algorithm and determined your car insurance should be more than mine for secret reasons, they're to blame. I mean, it seems to me that the accountability is there in terms of ethical and moral accountability, but it's not there are penalties to force them to reveal what's inside their box or to be penalized for charging people different amounts of money. I think morally the responsibility is pretty clear if you own a product.
So with your Facebook example, it's the company who runs the algorithms.
Well, certainly, yeah, because they're the ones that are they've selected what the training data is, they've selected what data they're making decisions on, they've selected all that infrastructure, and you by getting it for free, the premise is that you know, by their good graces of selecting these generous algorithms, you benefit, but they are still culpable for their own product.
Yeah, so I think the blame game is interesting exercise, but I think there's also a fact that, so let's take an example.
May I just say one sentence? Maybe the blaming part is wrong. Maybe we should also say who is to praise. I mean, there may also be a positive thing. We are so on the negative downside of things, but it's of course two parts of the thing. Sorry for interrupting you.
No problem. I think we're on the negative side because we are seeing too many of these law of unintended consequences arising. The case about that lady who was trying to cross the road on a bicycle that got run over by Uber. So here's an interesting thing, right? So what do we do when we as human beings want to cross the road and there's a car coming? Typically, we make eye contact with the driver, and there's some expectations that pass between us that the driver kind of either gives through a nod head, or through nodding his head or her head, or some unspoken communication tells us that, okay, I'll stop, you can cross. Where is that feedback in these automated cars, right? So did the automated car make eye contact with the lady? Did the automated car recognize that what was a bicycle was indeed a bicycle because the lady had handbags on her bicycle, grocery bags? And, you know, we tend to assume that our data that we are going to test on is taken from the same distribution as the data that we trained on. Is that a good assumption? I mean, that's one of the reasons why you take a stop sign and you put a couple of Band-Aids on it, suddenly it's not a stop sign anymore. It becomes, you know, drive at 45 miles per hour sign, right? Because the real world is far more random. The real world has much more context that needs to be assimilated in before a decision is made. And, you know, so the blame game, I think, will continue for the short time at least.
I always have a kind of different view when it comes to self-driving cars, because there's always this discussion about being careful about the ethics of self-driving cars. But I want to make the point that while we've been talking, 5 people have died in this country by human driving cars. So often another thing that happens in computing is we feel like we need to aim for perfection to the point where we're not going to cause any deaths by a self-driving car. But, you know, when you have 30,000 to 40,000 people a year dying in car accidents and computers never get drunk, drowsy, or distracted, you really have to think about and how when computers are saving lives, you have to be careful that you're not focusing on a few cases. I mean, it's tough. It's tough because you don't want to see anyone die, but and you know, computers never get any credit, you know, when they save a life. but you have to. These are very tough. These are very tough things to rely on, but to think about. But the real ultimate thing is how do we, you know, make the best of what we have. There's a lot of good that comes from computing, and how do we take advantage of that, realizing that they're never going to be, you know, by very nature, machine learning is a statistical thing. It's never going to be perfect. And but how do we get to that point that we kind of accept its imperfections the way we've, you know, we certainly accept imperfections from humans to some extent.
I mean, the Uber example is one where, as far as I know, I mean, we all in academic have to deal with institutional review boards because it was recognized after some pretty bad outcomes that individual researchers have biases and not of the racial or other kind, but of the, you're optimistic, otherwise you wouldn't work on, if you never believed that autonomous vehicle could save lives or make money or whatever, you wouldn't work on it in that. And that those biases towards optimizing your own objective function as opposed to some other metrics. And so one of the minimal things that I say is that commercial companies, as opposed to just universities, need much more external view of things where, so the question would have been, let's agree for a moment that long-term autonomous driving can save lives because it doesn't get drunk, it doesn't get distracted by looking at cell phones, whatever, in that, but we're far away from that. Because on an average basis, I think it's it's far too many deaths, but it's 1 death per million miles, as in most people will hopefully, in their whole driving history, never hurt or kill anybody. So the threshold is actually quite high. It's only a problem because people drive so much. So the problem that you had is you had no external review that said, well, yes, we agree that you should develop autonomous vehicles, but putting them out on the road and trying on real-life human beings is probably a bad idea. You should probably do some more lab testing in a simulated environment where, only Pac-Man dies, as opposed to a bicyclist. And we don't do enough of that, particularly for companies. There doesn't seem to be a requirement for companies to defend their decisions with societal impact to anybody but their board, maybe, who's clearly biased because they want to make money on the invention.
And actually, I would like to push back on well, why are we focusing on blame and not the thing? So we happen to have a real lawyer here. But what I would offer is, when us neophyte lawyer, David, us neophyte lawyer, or people who play lawyer, we think, oh, Congress passed a law. It's a law. Well, the thing is, it's not a law until a judge interprets it. It's not a law until basically somebody goes over the line and the judge says, yes, you went over the line. It's a cultural thing, and I guess the good, bad news, like we had the example of the Microsoft bot in the US and in China, and so we saw in different environments evolve differently. I could very well, having lived in Europe and imagine in Europe and having been to China a lot, acceptance of autonomous vehicles will probably be a lot higher in Europe because there's a belief that the government is working to protect you. In China, because it's a hierarchical, we're told to do it. In the United States, we also have to deal with issues like, isn't it great? The government will know where you are at all times. The government will know. In fact, here's like a difference in cultures. The government in the US will know when you go to a whorehouse. Bad. The government in the Netherlands will know when you go to the red light district. Okay, whatever. Everybody does it. It's legal. And so the cultural mores, and the thing is, in the United States, the mechanism we have is not there ought to be a law that companies should have an IRB. Companies get sued. Companies lose. A judge says, yep, you cross the line. Companies say, how can I protect them? Why? I would like to think that universities have institutional review boards because we want to do the right thing for people. Oh, by the way, all of our government funding is tied to having an institutional review board to protect the funders. Right? And so I think there's nothing wrong with saying who's got the liability, because whoever gets the liability is going to fix it. And yes, so Facebook is responsible, but they bought the algorithm, but they'll make sure that they buy good algorithm and they'll have indemnification. So for computer science, it's going to come down to you. You got to think really hard about what you're doing.
That's interesting. I was thinking, I'm from Europe, I was thinking, autonomous cars are so attractive, will be attractive to Americans because they will kind of increase their freedom, independence, do what they want, or they will be more flexible, can do other things. Well, and I mean, all of this. But I mean, I agree. If I understand, in my understanding, there are two levels. So one is the empirical thing that the system has to be trained better and has to not confound a bike with something else, and so on, and all of this. And the other is the question how the system actually does make its decisions, and how values play out here, cultural values, moral values. And this seems to be a huge problem, or this is a huge problem overall, not just in autonomous cars and in all kinds of AI systems, how to build values in moral decision-making, ethics. What are your thoughts on this? Is it necessary at all to build in values? I mean, maybe that's a way to start. Is it necessary at all?
So in fact, I'll put in a little IIT pitch, and I'll definitely put in a Georgetown pitch. So, when I got my PhD here, it was not, like a PhD in Java programming, right? It was specific research, but the goal was not just my thesis, but to go on and do more research, to learn how to do research and write it up and talk to people about it. It was about the process. And I think that is, the opportunity here. So should we be teaching how to create algorithms that have less bias or have purposeful anti-bias, which is a bias put in? Sure, but is that it? No. This is why, like at Georgetown, on the one hand, we in fact, it was at a debate where, like when I did my undergraduate, everyone had to take physics at my institution. And so we had physics for normal people, we had physics for masochists, which is, you had to have placed out all of the calculus to be even eligible to take the class. And then, we had physics for poets. And the thing is, I was talking with our provost at Georgetown, is, the concern is, we've got to have ethics training. And so that, we have ethics for engineers, which is kind of like the physics for poets, ethics for engineers. And that the idea is no, not just. And we do have an ethics requirement at Georgetown for all students. But we've actually just started, and I'll do a shout out to Mozilla Foundation. We got a Mozilla Foundation grant to actually integrate ethical thinking. Because by the time our undergraduates go on and start companies or go on and get their PhDs and do whatever, yeah, anti-bias maybe will be solved, but there'll be another ethical issue and another ethical issue. So to get students thinking about, what's the impact of what I do, and how does that fit into my society at large, to get people thinking about that a computer science degree or an engineering degree is more than just, do I know how to program, but am I programming for good?
Yeah, I do want to make a point to that, because I think that traditionally, and I'm not saying that the Georgetown one does that, ethics, if you look at the society, like IEEE and ACM have had ethics codes for decades, basically since their founding, I imagine, almost very close to that. And the performance, I'm guessing, I was not around and I was not clear of the history of it, was very much a individualistic ethics as a doctor and a lawyer might think of it. As a profession, you should, and probably as civil engineers, even if your boss tells you to take some shortcuts on that load design for that bridge, you shouldn't do that because, or your doctor, and all these good examples. What these ethical things tend to short circuit is they tend to focus on the individual behavior of individual actors as to what they should do, which is important. I'm not saying they shouldn't think of it as, but that tends to completely ignore the societal consideration of what is going on. Namely, just like doctors now should not just think about, am I prescribing the right medicine, and wasn't it because the sales rep for that particular medication just had given me a free lunch, but also how am I contributing to a medical system that is broken in many ways, that does not provide universal access, is what we don't do a good job of is what is my responsibility, and collectively what is the responsibility at the societal level, be it liability, be it laws, be it equity, be it reducing the impact of high stakes decisions, all of these things that go beyond, am I doing a responsible job and not, kind of, in ACM we had the risk culture, and it was very much of the, am I doing the right job as an individual contributor as opposed to a more larger one. And I think what we've learned is just relying on bachelor's degree recipients to put the burden of computer science ethics on their shoulders is asking too much and is asking too little.
So it's been a discussion like earlier about blame and about companies needing to be on top of things with their own review boards, but so maybe I'll go back to the original question about my research area, which is about complexity. It's about how hard it is to figure things out, where just a few simple rules can lead to an incredibly complex thing that's very hard to predict. And that's sort of what's happening in computing. It moves very fast, and it's very hard to predict what the ethical challenges are of what you're producing today. And I certainly never thought of, Mark Zuckerberg as someone who said, oh, well, I want to create a system that's going to allow people to manipulate elections. I'm sure that was not his goal or intent or anything he really wanted to do. And it's not like the rest of us were out there saying, your social network can be used in these evil ways. I think none of us realized what was going to happen. And yeah, they had a bit of a freewheeling attitude, but he had a goal of just wanting to connect people and allowing free speech and things that are endemic to our hearts. But when taken to the extremes, and something like Facebook lets you take it to the extremes, it opens up a huge amount of very bad behavior that can be out there. People manipulating people just, machine learning algorithms that shows people what they want to see, so that causes echo chambers and separates us instead of bringing us together, which I think was the original goal of a social network. So it's very, it's thinking sometimes it's easy to say, oh, these companies should have thought better, or they should have had some review board, or some ethics that they should have done. But I think it's just very, very difficult to understand what the outcomes. So we just have to be cognizant as best as we can and try to deal with issues as they come up. But don't underestimate the real difficulty of trying to predict how a technology today can be used in the future.
I mean, yes, a lot cannot be predicted, but aren't there some general principles that are helpful in guiding the development? For example, respect privacy, or informed consent of everybody involved, informed consent of users, lack of discrimination, fairness, principles like that, and they could help if there was a higher awareness of these things. Let's say informed consent, people would know better what would be done with what is being done with their data. They could prevent certain uses of their data, things like that. I mean, this could be some general rules or some general concepts to kind of establish as central. What do you think?
Some people have talked about something called abusability testing for AI, where you think about if you use kind of like IIT is really good at design. There's the Design Institute here, and they do something called foresight thinking. And there's been some proposals that we do a lot more than an AI. So you really think of not just like, oh, this is super useful. And I think back to a few months ago reading the story about the robot that wheeled its way into the guy's room to tell him, guess what, you're dying. Super efficient. An engineer designed this robot to come and say you're dying. It seems really efficient, not the best use of a robot. And had we use some design, some foresight thinking to think, what are the really, really great uses of AI? Computer vision to diagnose illnesses, but what are the really, what's the spectrum of things? I think computer scientists, AI people, machine learning need to partner more with more design people and people who think, it goes beyond your classic kind of UX, like design of an interface. It's really thinking about system designs, to think about things like privacy. People don't care about privacy implications. I mean, this is not a battle we fight all the time. Where if you think about what Facebook's doing with your data, by and large, its studies have shown time and again, people want convenience. They don't necessarily care. Should they care? That's a different story, but they don't. But this kind of more robust interactions, I think, with design could serve us well in computer science.
Now, I'll just say one thing to kind of encounter to what was just said. Facebook is a good example of designing without safety. Namely, they could have asked a media historian, which I'm not. It's certainly not the first time that a new medium has been used for propaganda. Father Coughlin on the radio is not a new thing. Many of us have heard of this guy, even if we've never heard him actually. Rwanda had happened on the radio, where people literally killed others because of ethnicity in that. Just nobody bothered to ask. And secondly, it was a good example where it became obvious that these systems had significant risks, safety risks, and the reaction to that was we do the minimum necessary to get the politicians, the journalists of our back, as opposed to designing systems where we can tune back the knobs in that when it turns out that the thing maybe shouldn't be running that fast. Maybe we should limit the spread of information in that when it turns out that the information that spreads leads to really bad outcome, as in people get killed. So I don't blame, it is not one where this was the exact outcome could not be predicted by that. That's true. But if you're operating in a dynamic environment, if you don't design your system for well-known human characteristics, and you don't build in safety mechanism where you can very quickly adjust to that, like we do in other engineered systems, where you have usually a fallback mode in that, you have emergency brakes, you have all kinds of things that you have backup systems that you do. Then, yes, I blame Facebook in particular and other companies like that they didn't design their system of safety in mind, which in other engineering disciplines gets you fired or worse. And in computer science, we seem to tolerate.
But Facebook's very fundamental system runs on privacy violations. I mean, it runs on the fact that, I mean, I guess that word itself is open interpretation, but the very foundation of the system is run on the fact that they are taking data that people don't know they are giving up. I mean, I think that's the difference.
Well, there's several aspects.
Obviously, that's now very complicated aspects and very controversial topics. I would like to open the discussion to all of you, to all the participants, and let's spend the rest of the time we have on questions you have, comments, whatever.
So, you mentioned a car hitting a lady on a bike, which I've never heard about, but after I thought about it, you were saying that the car couldn't recognize the lady because there were some bags on the car, on the bike, which made the bike not look like a bike, perhaps. And so my question after I thought about that was like, well, wasn't a person driving, so what difference does it make what the car thought?
Now, this was a self-driving car.
Really?
No driver.
No driver.
On a real street?
On a real street.
Well,
It's
that's
not
the
a
point.
simulation? It wasn't a simulation? They weren't testing?
No.
No, they're
So
out there in the
there
streets of
was a
Pittsburgh
safety
and
driver, but the
different
safety
places.
driver was distracted because most of the time, I mean, you designed a system, and again, this has been known since the beginnings of railroads, that if you have a position which 99% of the time that has nothing to do, expecting the person to be fully alert and react on an instant's notice in that 1% when there's a bicyclist is just a design that is fundamentally flawed. And any psychologist would have told Uber that if Uber had asked. This is not new knowledge.
Yeah, I'm really interested in tech, and particularly as an African American male. I'm really, I've been thinking about this whole thing about tech ethics as we move further and further into tech. I mean, if we can't deal with a society that basically has a lot of discriminations and biases and unfairnesses, is it really realistic to expect for tech to handle those situations? I mean, you look at our law. Our law is supposed to deal with that, and it hasn't dealt with it fairly in this society. So what is really the role of tech? What is the expectation of tech? And, you know, what is the realism there? It's just my thought.
First, don't make it worse.
Do no more harm?
I think we, you know, there's no doubt that we're failing there. I mean, we're failing there on many. We're also don't have a great, you know, look at this, look at our panelists here. We don't have a, there's not a lot of great diversity in the tech community itself, and I think we need more of that in order to get the viewpoints from a broader base of people, so we even understand what we're not doing right. You know, used properly, tech can make great advances because you know, humans tend to be inherently biased, even when they try not to be. So I think tech can help us try to understand the problems, and we can try to frame them and try to help them. Are we going to get perfection? I don't. You know, we'll never get perfection, but I think we can try to help.
Yeah, so what I was going to say is going to be close to a comment on that, which is, I mean, became an engineer decades ago and was always a bit conflicted about it because I felt like somehow engineers were conservative and they had to keep the status quo or something like this. And I was kind of ambivalent for a long time. And in a way, we're talking about the engineers aren't going to solve the problem. Not one element of the society is going to solve the problem. And we all are human and part of the society. So we all are, have failings. And our solutions, we do have to be pulled back from the edge. And we have to modulate what we're doing. So if I'm doing machine learning, for example, I need to be aware that I need to modulate the solutions that the machine is giving me using my social awareness and my humanity and so forth. And we're part of the solution and we're probably part of the problem. But as long as we don't think that our current state is the final the final answer to the problems, and we don't give up our autonomy or societies to some machine, I think that we struggle onward. So I think that this technology is part of the answer.
I think what we need is an interdisciplinary effort and have a lot of disciplines involved, not just computer science and not just blaming computer science, but the social science, ethics, philosophy, psychology, design, history, politics, all kinds of fields, and stakeholders in the various fields, and have a discussion together and try to solve these things together. I think you are next, and then it's you.
Okay, in 21st century, I think this inflection point is the best thing ever happened to the humanity, to displace it from its comfort zone or / status quo. But the way machine learning is applied, it's got a little biases because it's poor statistical analysis. The data that's harvested, it's got lots of noise. It's very hard to really ascertain the particular data. But one has to come up with specific instrumentation and more precise in order to really cleanse the data to make decisions. When it comes to population displacement, biases and all of that, it's an inherent characteristics of human. 75% of global population suffer from some form of cognitive dysfunctions / some chronic diseases. We don't see it, it's underneath. It's not visible to naked eye. Our present system, barely 2% efficiency. So cross-disciplinary, I think this is the ideal. Everybody's got stuck at it. But I don't see most of the solutions that exist out there right now are not solving actual problem, are contributing to the problem. The essence is to get multiple stakeholders and create some sort of a 360 solution to integrate, to benefit each other, because we live in a dynamical world. Things are becoming obsolete on a weekly basis. So let's not blame each other. Let's come up with a solution. Everybody's part of the solutions, basically. Thank you.
Last question?
Yeah. Hi, thank you. So the point is that like unintentional bias can also be introduced in like algorithmic design, right? Because normally people would say machine learning algorithm would just reflect the data that is given to it. But one example that I got from my favorite podcast, Linear Digression, was that, there's a very famous example for machine learning is called analogy task. So basically, a queen minus woman would be equal to a king minus a man. So this is how you do like word to vec, some like embedding task. And what's terrible is that if you do doctor minus man plus woman, you would get nurse back. This is terrible. This is terrible. And initially people would believe, oh, this is just from the learning text, the data. But there's some paper analyzing the actual algorithm. They actually discovered that there's a constraint in their training. So like, for example, A is to D, A is to B as C is to D, right? They are like constraining, like A, B, C, D cannot be the same. So that partially explained why women cannot be doctor, because man is already a doctor. So it's forced to women to be a nurse. That's in the algorithm design. So this is actually very terrible. But I don't believe, the designer, they have such bias in their mind, but it's just algorithmic. Maybe they're just trying to do a better optimization task, because basically it's gradient descent. Maybe they're just trying to optimize accuracy. But, this kind of, in optimization, we always have some constraints, and it's algorithmic. It's algorithm, but but it has some physical meaning after the result comes out. So maybe we have to be more vigilant in designing too. We cannot just blame data. This is a comment.
Yeah, so I'll just make one. Again, I want to just emphasize that emphasizing individual responsibilities are good and great. If we look at, and I will disagree that we are actually from under fundamental distinction, that our progress has been so much more radical. I would argue that somebody entering the 20th century had far more radical transformation than we did. We have better advertising technology, which is largely what we've created, as opposed to somebody who can fly when they couldn't as a kid, who could drive long distances, who had penicillin, all the things that I don't have to go through. What we don't have, we had a much better sense after some really dramatic all of those technologies were quite dangerous to begin with. Cars were individually dangerous, trains were, planes were, but there was a notion that constraints would be imposed that would limit the inherent incentives of the operators of these inherently dangerous technologies to do what was just good for the immediate profit maximization. We have lost that. The idea that potentially, and this is why I said dual-use technologies, we do that for chemicals. We do that with chlorine. We have decided for some reason that Mr. Zuckerberg can just simply do whatever he wants to, that other companies that make equally dangerous stuff should just be able to do whatever they want to without any external liability, without any external review, and without even a sense that this is something that can be addressed at a larger scale than just the responsibility of individual engineers.
Unfortunately, we have to stop here because our time is over. I would like to thank all of you. I would like to thank the panelists, all of you who contributed to the discussion, all of you who stayed here, and a particular thank I want to express to my students from the Ethics of Information and Communications Technology class who are sitting behind here and who came and stayed during the whole discussion. Okay, thanks everybody.